Okay, good afternoon, good evening. So continuation, I want to do some explanation on data input or data import in Matlab before I touch on functions. We'll have to do functions today. Then I will now do symbolic computations in Matlab before I'll round up with introduction to Simulink so that we can finish up everything about MATLAB this week. And by next week, you should be able to finish up with your assignments on MATLAB, and then we take on the AutoCAD. Now, I'm going to share my screen quickly. Yes, I am quickly looking at the example 2 of the data import in MATLAB. So importing data in MATLAB means loading data from an external file, and it's very, very important for you to know because you may need to use it to do your analysis, to run your analysis. MATLAB has a lot of functions to do data analysis, and that's even very powerful. You can do a lot of 3D image processing. Graphical output of your data. So in MATLAB. So that's why you may need to import data from Excel, from even SPSS. So if you can take from SPSS to Excel, you can import into MATLAB. Even from other statistical packages. Moment they are in Excel format, they can also be imported from text files. So all these things can be done. So look at this example. In this example, we import a text file and specify the limiter and column header, and then the file is named weekly-data.txt. Okay, our text file weekly-data looks like this in the text file. Okay, Sunday, Monday, Tuesday. Now this is probably what has been recorded. So probably you are carrying out an experiment or you're carrying out a measurement on certain certain factors or parameters or events or whatever. Like I did a research with one of a PhD student, and we had to do measurement of the humidity, the temperature, and especially it's talking about the atmospherical conditions, atmospheric pressure, atmospheric temperature, humidity, and all this, so that we can know in Harmattan and in normal season. And the experiment was quite and this can be done. We can analyze data in SPSS or in MATLAB. So with this, we can bring this file from Excel or from text file into MATLAB. So look at this data that have been put into this weekly data.txt. So if you don't have it, so you need to create it. So this is to serve as an experiment for you to do. As an assignment for you to do. You type this data from your notepad. Okay. Let me launch Notepad. From Notepad, you can actually do this. Okay, I'm launching Notepad now. Okay, now I'm launching Notepad. Then I can just copy this data. I don't want to type into Notepad. Okay, so let me see whether I can share this Notepad. Okay, so this is what I've done here. So I've already pasted it on here. So I can now save it. I can save as I'll make sure I select Matlab folder, okay? Matlab folder on my document, okay? So that it can be easily accessed from there. So I will just type weekly, okay, I have to use small letter, weekly data. So the .txt. Let me unmute. Sorry, I'm back again. So I'm trying to look at where I stopped. Okay, you can see my screen. This is where I'm supposed to be. Let me see. Yeah. So this, I've already saved it. You can see I've saved it as weekly data, and I make sure I save it in Matlab directory. So let me see whether you are seeing what I'm sharing. Yes, you can see, so that you can see what I'm sharing. I've saved it in Matlab. Inside my document, I look for the Matlab directory and I'm saving it there. So it has been saved and says you want to override, I'll just save it. So that has been done now, okay? So let me come back to my new share. Okay, so I'm now here. Now this has been saved now. Now we now create a script, create a file, a script file, and type the following code, okay? Now file name this, delimiter this. Now A is going to import file name delimiter. These are the delimiter it's going to use. That is what we will separate it. And then header line. Now I want to view the data for K is equal to 1 to 7. Display this. So, so when we run this, look at how it's going to be. So it's going to be, okay? Now, let me quickly test this. Let me create this script quickly. So I have the Matlab open here. Okay, let me clear my screen here for this one to be clear. You can see this is my command history. I can bring out. So let me create, open another script file. Now you can see from here. Now because my Matlab is my present working directory. So if I type pwd, you can see. If you're not sure of your present working directory, you can type pwd and it will tell you you are in Matlab. Okay. So with this, I am good to go. With this, I can run this. So let me run it. I need to save it as a data input. Let me just see data input 1. Okay. So that is data import. Okay. Now you can see. Now you can see the delimiter. This is a new line, I think. You can see limiter is a space. Okay. So if you look at this output here, you will see what is being done. So the header line is picking from the data, the header. You can see from Sunday, it picks, and you can see where is that that data. You already saw it when you were creating it. So this is what display here. So then this is the file name, weekly data that is being imported into this array A. Then, but this is the way it's going to do it. delimiter is going to have this space, then it's going to have this header line, and then so this is a space used for the delimiter, and then the header line is 1. It's going to pick 1, the header line. So that is the row line, the row of the header line. Okay, so this is what you will see as the output of it. Now if I so you can see this is what is to having imported this into A. Now to view the content of the data and to send it to the screen, we use this loop for K. And see this for K equal to 1 to 7 because it's 1 to 7. Then we have display. This one we send it to the screen A dot column header. Okay. LK. Let me see. Yeah. Then L comma K. Okay. That is the column header. So then display A dot data. Now this is let me see here. Yes. Then we have display. Now you can see it's picking the row K. I mean, this is what we talked about the other time. It's going to display the kth row. Okay. I mean, on that sorry, column, the kth column. Okay. And then it will display this. So if I want to know what that is doing, I can put comments and try to run. Can you see? So this is actually what displays the data underneath the column. So this one displays this command display the header. Okay. This one displays the data, the underneath data. Then this one, you can see if I do this, this will remove the space. So this is how to study your code if you are having, can you see? The spaces are removed because this is just to introduce space. That's code with space. That's what this is doing. So this is how to really understand your code. And so if I remove this now, you will see that those things will be done. So if I run again, can you see now? So can you see? So this is what has been done. So I think with this, let me move to the next. Okay, I'll finish with this. So let me stop sharing. Let me do a new share. Okay. Now this is what we have just done, and this is the output, which is correct, which is the same. So in example 3, in this example, you can import data from clipboard. Now, just type this and copy it with Control-C, and then create a script. A is going to import data, bracket, open and close, then quotes dash page special. When you run this in a script, you have this. A is equal to mathematics. It's simple. Then these are the low-level file input output, which you need to put after. So the import data function is a high-level function. Okay, low-level file input output function in Matlab allow the most control over reading and writing data to a file. But this function needs more detailed information about your file to work efficiently. So you need to look at the following functions for read and write operations at the byte and character level. Okay, fclose, file EOF stands for end of file, input output file error, F error, F get, F open, F print F, write that to a text file, F read data from binary file, F rewind, move file position indicator to beginning of open file, F scan, F read data from text file, F seek, move to specified position in file, F tell, position in open file, F write data to binary file. So you can see all this can be used. When you have any need of it, you can just do help and the function. The Matlab will give you the format of using them. Matlab provides following function for low-level import of text data. Okay, F scan F, which reads formatted data in a text or ASCII file. Then F get L and F get S functions read one line of a file at a time, where a new line character separates each line. Okay. Then the F read function reads a stream of data at the byte or bit level. Now, this is an example. Now, let's say an example that a text data file, my file that's saved in our working directory, and then the file store rainfall data for 3 months, June, July, and August for the year 2012. And then the data contains repeated set of time, month, and so this is how the file look like. So rainfall data, blah blah blah, and then this is what it has recorded. Okay, in that data. So you can try it. Then we will now import data from this file and display the data. You can open the file with fopen function and get the file identifier. Now you can now describe the data in the file with format specifier. Okay, such as %x for string, %d for integer, %f for floating point number. So you can see when you see these things, that's what it means. So I ask what is %x standing for, and in the format specifier, it's standing for a string. %d standing for integer. %f is standing for floating point number. Actually, floating point numbers are regarded as decimal numbers. So you need to take note of that. Decimal numbers that have decimal points after them, they are called floating point number. Now, to skip literal character in the file, include them in the format description. To skip a data file, use an asterisk in the specifier. Okay. So this is an example to read the header and return the single value for M. So this is it here. Okay, this is for string, and then it's taking this. By default, F scan F data according to our format description until it does not find any match for the data, or it reaches the end of the file. Here we will use for loop for reading 3 sets of data, and each time it will read 7 rows, 5 columns. Now look at it. This will create a structure named my data in the workspace to store. We'll create a structure named my data in the workspace to store data read from the file. This structure has 3 fields: time, month, and rain data array. Now with this, you can have file name is equal to this is getting it from data, my file. Okay. Now row is equal to 7, column is equal to 5, then open the file ID F open file name, so the previous one, and then read the file header. Then this is going to read it, number of months, and then for each set of measurements, you're going to read the 1 to M. M is it's going to find the M. M is going to scan and find where M is. So 1 to M, then for N, then my data is this, going to scan that, and it's going to read this, and then F scan F will fill the array in column order, and so transpose the result. Okay, this is what we'll have here. Rows column, and then this is it's going to accept floating point decimal places. Then end, this is for the first loop. Then for N is got the 1 to N, display. It's now displaying what is in this place. Display this one. This is what is displaying. here. Okay. And this is what is displaying here. Okay, so when this is run, you will see this will be the output. Then we now display this. So you have close the file, then F close FID. So when you run it, it will read it in like this, and then it will display. This is the display. Okay. Okay, so this is really interesting. This is interesting. So this is just to give us a closer look at the data import function of Matlab for you to import data. So I believe this will help if you have any project, anything that has to do with this. So quickly, I'm going to move to functions in Matlab. Functions. Let me quickly move to functions. Let me see if I can move to functions. Let me see if I move to functions. Okay, we've done data output. This is what we did last time. Let me move to functions. No plotting. No, I'm not going to do that. Let me quickly go back. I want to go to function straight. Plotting will be later. Okay. Okay, Matlab functions, very, very important. A function is a group of statements that together perform a task. So it means that one of the statement cannot stand alone. They have to perform tasks together. So in Matlab, functions are defined in separate files. The name of the file and of the function should be the same. Very, very important. Functions operate on variable within their own workspace, which is also called the local workspace. It's separate from the workspace you access at the Matlab command prompt, which is called the base workspace. Okay, very, very important for you to take note of that. Functions can accept more than one input arguments, or may return more than one output arguments. Syntax of a function statement is you have the function, then these are the output arguments, then these are going to be, this is the function name, and it will be the input arguments. So the following example will serve. So let's look at mymax. The file name will be mymax.m. It takes about 5 numbers as argument and returns the maximum of the number. So I'm going to try this so that we can see. Now, this will create a function file, name mymax.m, and type the following code in it. Okay. Okay, we have to do this. Yeah, this is an example. So try to do this also as an assignment and submit so that you can really know what. Just try new script. Okay. Let me clear this screen here. Okay. Let me see whether. Okay, let me just. I'm going to create the file, the function file, and I will save it. Okay, the moment Matlab sees function, is going to save it with my max.m. So let me try to run it. Okay, to save it as mymax.m. So it's in the Matlab folder. Good. Now to run this function calculates the maximum of 5 numbers given as input. You can see these are comments to make this program usable, to make this program very explicit. Okay, so this function calculates the maximum of 5 numbers given as input. So that means this is going to take 1, 2, 3, 4, 5. So I must supply these 5 inputs either at my running the function or inside the function itself. So let me just, I want to run the function. I'll say my max. Then I will put the numbers. I want to see I want to see the maximum of this 1, 2, 3, 4, 5. Okay. Okay, it takes about 5. So what I'm going to do, let me change this so that I don't. So let me change this. So it must take at least 5 input arguments. That is 5 inputs. So when I do that, okay, you can see this. Immediately it displays to me that this is the maximum number there is 20. It's 20. Sorry, I'm doing an online class. So you can see the maximum number there is 20. And this means that MATLAB will check, the code will check, the first one is going to start from mass is equal to N1, okay? If N2 is greater than mass. So what it's doing here is actually setting the first number that I enter. And don't forget, in this case, it's 20, okay? So it's going to say mass is equal to 20, which is N1, okay? So it's going to check if N2 is greater than mass, then mass is now equal to N2. Can you see the logic there? Immediately it checks and it's okay, is 20 greater than, is 5 greater than 20? And it sees that 5 is not greater than 20. It will not set mass is equal to N2. Because as it checks it and it discovers that it is not, immediately it's going to make sure that it keeps the max to still be N1, which is 20. Okay, I just want to use the example to teach this concept. Now, again, it checks if N, okay, it will end that. Now, if N3 is greater than max, max has been set to be N1, and N1 is 20. So it checks N3, which is 7. Now, 7 is not greater than 20, so it won't do anything. It will end. It won't set mass is equal to N3. It will check again, because mass is still set to be N1, okay? Now, it will check again if N4 is greater than max. N4 is 8 here. Now, N4 is not greater than N1, which is already set at max, which is 20. So it will not set max to become 8, okay? The same thing if N5 is greater than max. Max has been set to be N1, which is 20, okay? So when it checks and it says that N5 is 10, and is 10 greater than 20? No. So it will not replace mass will be equals to N, and then it will end it. So at the end of the day, it will pick mass is equal to N1, which it has stored here, and return it as 20. Can you imagine? Now let me run it with another input. Now let me say 1, 2, 4, 6, 7. So let me close this. 1, 2, 4, 6, 7. Now watch this. 7. You can see this is very, very pretty. Now in this case, mass will be set to N1, which is 1. But by the time it begins to compare, N2 is greater than max, it will change max to become 2. Okay? Now, if we are going to, now, I just want to show you the intermediate, let me quickly show the intermediate output so that you can understand how the program runs. Okay, now I just want to run it now. Just watch me so that you can see how it works. Okay, sorry. Let me bring up the last, okay, just watch it. Can you see now? So here, it starts from mass is equal to 1. By the time it checks it, the next one is greater than 1. It changes to 2. The next one is greater than 2. It's getting to 4. Next is greater than 4. It's getting to 6. So, and then now the max is now 7. So that's the final. Can you see? So if I just look at this, this is beautiful. And let me run this now. Okay, can you see? Now, can you see that? Can you see that all along max has been set to 20, and all the other ones they could not meet that condition of being greater than 20. So it did not save them to be max inside max. So these are the ways you can really troubleshoot and find out how your program operates by removing the semicolon to find out the intermediate outputs of your program so that you can know where there is a problem. Now, this is how you actually debug or you find out, semantic errors in your program. Syntax can be easily, because syntax will not even allow the program to run. Semantics will program may run but not perform as expected. So this is really, really cool. Functions are very, very important for us to master. So, and you see how it is. So I'm going to give us some example and some assignment in that line too. Now let me quickly move to the next example. Let me stop sharing. Let me pick a new share. Okay, so we have just finished this. Now you can see the first line of the function starts with the keyword function. It gives the name of the function and order of arguments. Okay. Now, example, the math function has 5 input arguments and 1 output argument. Okay, you can see the comment lines come right after the function. That's why. So this line I printed when you type help my math. Okay, so Matlab will execute the above statement and return the following. This function calculates the maximum. So when you type help my maths, it will look at the comments that are, conspicuous there and give it out to you. So then you can call the function with this. You must specify the input arguments, the input data. And then here you can see here it says that this is 89. Now we also have anonymous function. This is like an inline function in traditional programming language, defined within a single Matlab statement, consists of a single Matlab expression and any number of inputs and output arguments. So you can define anonymous function right at the Matlab command or within a function or script. Now, let's look at how this works. We can create simple function without having to create a file for them. Okay. Now, this is this is an inline function. In between the traditional programming language. So you can use them inline. So F is equal to argument list expression. So this becomes a function. This is the syntax. Okay, the syntax for creating an anonymous function from an expression is this. So take note of this. Very, very important. Very, very important. Must come. F. So in this example, we will write an anonymous function named power, which will take care 2 numbers as input and return first number raised to the power of the second number. Okay. So we can create this script, and then this will now make this to run. So this is the, so when you want to run, it will give you this. So let's quickly, so this is like inline function, no, function inside a program. So let's quickly look at it. Let me start a new script. I can also do it on command line. Okay, let me, it's good to clear your screen even in your script language. So let's see how this works. Let's say power. Okay, we cannot save as power. Okay. Okay. So I can see I must not give it the name power. Let me give it another name. Let me give it yes. I need to change it to, let me save it as let me say power 1. Okay, good. So let me, good. So this is better because it cannot be the same name as the power. Okay, you can see. Okay, let me run it again. Power 1. Okay, so you can see what it's doing here. It's taking the result is equal to power 73. So this is power is equal to at, this at sign is creating the function xn, taking two input arguments, and then is now raising the power, raising that the first one to the power of n. This is, just like array power operator here. Okay, so it does this. So this one will give us result 1. You come here, result 1 will be this 7 raised to power 3. Then this one will be 49 raised to power half, which is almost like square root. Then this is result 3 will be 10 raised to power minus 10. We're going to have this. And then result 4 is going to be power, that means 4.5 raised to power, 1.5. So that's what you see here. Very, very cool. No, so it's calling the function inside the script. That means the values for the input argument are supplied inside the script itself. So this is very, very cool, very, very handy for us to use. If you want to make sure that that function runs with the input argument inside the script, that you don't need to supply it from outside, that is a good. So this is called anonymous function. Take note of this. Anonymous function. Anonymous function. Anonymous function. Yes, this is called anonymous function. Okay. Because the script itself cannot be named with the same name of the function. That's why I have to use power 1 as the name of the script. But the name of the function is power. Okay. So take note of this so that you will not be confused. So this is a power is the name of the function. Now the script where I run it. Now this can just be a command you type from the keyboard and it will from the command window and it will run. No problem because you did not save it. But when you save it as a script, you must not save the script with the name of the function, because the function name is power, and it will not, but the script itself cannot be power, because inside the script it will be calling the power, and that will be a little bit confusing. So that's what we have now. Then we now have primary and sub functions. Okay. Any function other than anonymous function must be defined within a file. So that's each function file contains a required primary function that appears first, and any number of optional sub functions that comes after the primary function and used by it. Primary function can be called from outside of the file that defines them. Okay, while anonymous function must be called within that, script file. Now, either from command line or from other functions. But some functions cannot be called from command line or other functions outside the function file. Okay, so some functions will be called from the function file. Sub functions are available only to the primary functions and other sub functions within this function file that defines them. So when we have the primary function, sub functions, they can only be called inside the primary function. Let's look at an example here. This makes it very explicit. Look at, want to write a function named quadratic function that will calculate the roots of a quadratic equation. Then the function will take 3 inputs. Now, the quadratic coefficients, the linear coefficients, and the constant term, it will return the roots. And then the function files will be saved as quadratic.m. It will contain the primary function quadratic and the sub-function disk, which calculates the discriminant. Okay? Now, let's look at it. Now, we create this in our script file. We name it quadratic.m. Now, because the function actually takes, has 2 outputs, argument, and 3 input arguments. You can see that. Okay? So this function returns the roots of quadratic equation. So it takes 3 input arguments, and which are the coefficient of x2 and x1, and the constant term. Then x and the constant terms. Okay, it returns the root. Okay, now D is equal to the disk A, B, C. That's discriminant. Now it's going to be the x1 equal to this, x2 is equal to this. So this is what will be taken, and then these are the roots. Okay, so the function displays 2 outputs of the root of the equation, of the quadratic equation. So x1 will be minus b plus d over 2 times a. Remember that. Before we used to have that square root, but then you have minus b minus d divided by 2 times a. So it's going to take, so then function this will be a sub-function. It will calculate discriminant. This is equal to square root of b. This is what actually will be needed. Okay. This is the end of subfunction. So we have square root of b squared minus 4 times a times 6. Okay, that is the quadratic equation. That's supposed to be the almighty formula. So we can call this above function from command prompt by using quadratic 2, 4, minus 4. These are supposed to be the coefficient of x2. Okay. Now, this Matlab will still and return the following. Answer is this. So the answer will be this discriminant here. Okay, this D here will be returned because now you can actually display x1, x2. So let's look at it. Let me create this function file so that we can explore it. So it's good to explore and probe. Okay. Um, let me do a new share. Okay. Let me a new script I want to open here. Okay. Look at this. I'm saving it as quadratic, and I'm going to experiment. I'm going to test it. Okay. Yeah, that's the first thing. You save it. I'm saving the Matlab document folder. Okay, now you can see it's already telling me because by the time it saves it, it's going to, I mean, by the time I run, I'm supposed to save it without clicking run, but I clicked on run. So before it can run, it will save and try to run. But if it doesn't see the arguments, it will give error. The input arguments are not enough. So now what I'm going to do now, let me quickly clear my screen, clear my console. Now I want to look at, okay, let me run it with, let me run quadratic with the input argument. Let me just give the exact, the exact, let me use the exact 4, let me use the exact one use here, 2, 4, minus 4. Okay, 2, 4, then minus 4. Okay, so now you can see. Okay. Yeah. I remember. Yes, they are warning me that the function power I did before is having that problem. So I'm going to rename it because it's going to have the same problem with Matlab function. So that is one of the things I've been warning me of. So I will do that quickly. Let me do that very quickly so that it doesn't interfere with I will call this later. Let me open that function. Let me open that function called power. Okay, this is the one now. Okay. Should be power dot A. Let me say power dot A. Let me say power 2. And how to use this to call them. Okay. Let me see whether it works. Yeah. Okay. There's a problem that I'm trying to solve now. Yes, this power. Let me see. This power. Let me delete it. Okay. Yes. Okay, let me do it. Okay, I think this is better now. Yeah. Okay. Let me clear this. Let me run it again. Means whether it's still having the same problem. No, it doesn't have now because I've changed it. Yes, I've changed it to power 1, which is better. Good. This is better. So I've solved that problem that is causing conflict because I'm using the same power for my function as the same as the one in MATLAB. So that's so let me now focus on the one we are doing now, quadratic. Okay, now quadratic, yes. Now let me run this quadratic with that. Let me run the quadratic function with the three input arguments, 4, -4. Okay, it's work now. So okay, you can see it's work now. Now, for instance, if I have to remove this for me to see the intermediate output, let me run it again. Can you see? Now this this is this. To take this ABC first and work on them. So this will be D. Then D is equal to discriminant of this. Okay, let me look at this. Let me see this. Let me see whether to save it. Okay, good. Now let me. Yes. Okay, so I'm looking for. Now it's going to give me the D. This is discriminant. Now this is the X1. This is the X2. Can you see? This are the. Then it's going to give me the answer is this. This is discriminant, and this is what we have here. So it's really interesting if you can check some of what you're doing and see how it works out. So this is a sub function, and this is the end of the sub function. Okay, so this is called. You can see this one is called from here. Okay, this is a function called from okay, this is the D here, and then this is sorry, this is a sub function calling this. So this is a function from MATLAB, and this is the one here. Let me see undefined function variable. This is okay. This is what is being assigned to do the discriminants of the inputs here. So this is how this is gotten here. So let me run it again so that you can see. So you can see D. Can you see it? You can see this is D. This is okay. So this is the value of D that will be used here. So this is really interesting. So let's move to nested functions. This function, then function inside function. So this is function, this, then function, this, then this, and this. So it's almost very close. So you can call the above function from command this, and you will have the same thing. So this is a nested function. Instead of sub function, you can define function within the body of another function. These are called nested function. Nested function contains any or all of the components of any other function. Okay. Nested functions are defined within the scope. Let me be sure I am Okay, nested function. Now, this okay. Now, this is that's sometimes when we need the scope of another function, and they share access to the containing functions workspace. So this is syntax function x a. These are the input arguments. This is, then we have blah blah blah. Then b. Then we have whatever. Then function y is equal to b is equal to p3, and then we end. So this is nested function inside function. And let us write the function quadratic in a new way by using the nested function. So you can now make it quadratic 2 and do this. So function disk will now be nested. So this is function disk, then this is function disk inside now. This would now be d is now this. This is end of function disk, okay? That's to get the discriminant. And then this disk will be called here, and then this will give you the roots of the equation, and then you will now end the function here. So when you run this, this is it there. So because you are suppressing this, only this output disk quadratic will be sent to the answer. Then we have private functions. A private function is a primary function that is visible only to a limited group of other functions. If you do not want to expose the implementation of a function or a function of functions, you can create them as private functions. You don't want to expose the implementation of a function or more than one function. You create them as private functions. Private functions reside in subfolders with this special name, private, okay? They are visible only to the function in the parent folder. So let's see quadratic function written as a private function. So this function containing discriminant will be a private function. So inside, so that means it will be, we create a subfolder named private in working directory. Then we store the function dix.m in it. This will be a private function, and then we now write the function quadratic 3.m in the working directory. So this will be the code now, as we've done before. Then this function will return the roots of the quadratic equation. It takes 3 input arguments, which are the coefficients of S, and then return the roots of D and this and this. So what is going to happen now is going to call this disk from the private directory, from the private subfolder in the working directory. So because it is stored there. So this is just what will be there. So it's just like a sub function, but a private function, Now, because it will be stored in the subfolder with a special name private. So these are different ways you can do the same thing. Then let's look at global variables. Global variable can be stored by more than one function. It can be shared by more than one function. For this, you need to declare the variable as global in all the functions. You want to access that variable from the base workspace, then declare the variable at the command line. Or whatever. The global declaration must occur before the variable is actually used in a function. It is a good practice to use capital letters for the names of global variables to distinguish them from other variables. Okay, so capital letters are advised. Okay, let us create a function file named average.m and type the following code. Function average is equal to average num is the argument here, input argument. Global total. Average is equal to sum nums divided by total. Then we have end. So create a script file and type the following code in it. Global total 2 is equal to 10. Then n is equal to this 34, 45, 25, 45, 33, 19, 40, 34, 38, 42. And then average AF is equal to average of n. Now, when you run the file, you already have average.m. Then you already have this one. When you run this, you have to probably save it with another name. And then you will have this. So now let's quickly do this and see how it works before I call it a day from functions. Functions. Yes. Okay. Let me come to Matlab screen share. Let me do a new script. Okay, that's function average. Okay. Let me save it first. Average. Okay. Let me do another script. Now let me supply this. Okay. Now this is let me run this script. Let me just say AV1. Just okay. So because AV1 has supplied the input, so it's going to call the global total from the other one. Let me see whether I can probably. This is what I can do. Let me minimize. Okay, sorry. Okay, you can see. Let me open. Let me also open. I need to see if I can have more than. Okay. So let me open this. Let me run it. Let me see where's my command. And to bring out my command. Yes. Yeah, this is my command. This is my. I need to dock that thing. Let me see. I want to dock it. I want to dock this. Let me remove this. Let me close the hand so that I can dock. Let me. It's going to overlap. I don't know. Let me. I want to see if I can. Thank you. I have to call it a day. Bye for now.